We're at Daytona Beach in the spacesuit lab, where they take a look at the different spacesuits and in many cases evaluate the spacesuits and the movement in that. I have Ryan here, the expert with the spacesuit lab. Brian, can you tell us a little bit about what you do here and about the motion capture and how you use simulation?
Sure. Well, with motion capture, we can really capture the 3D imaging of what's going on with the user, such as an astronaut in a spacesuit, where traditionally they just look at two-dimensional, looking at kind of a front plane view and watching the astronaut's movements with a grid and measuring how much performance is lost by the inability to move because of this extra garment on. So here in the lab, we're able to do a few different things. We can do the video work as well, compared to the historical data of how spacesuits have been measured. But now with 3D motion capture, we can actually look at all that 3D interaction that's missing from all the movements that you might see. We can actually push it a little bit further, get a full cloud of data of the work envelope and the range of motion that an astronaut would see either in a seated position or lying down. A lot of variability with what we can test here. Just need the enough space and enough cameras, and we're able to do anything in here.
Right. And this suit you have here looks like that's a motion capture suit. How is that used with this space suit, and how you design that?
So the great thing with motion capture is that you can really break it down to the fundamental skeleton shapes of movement. So you can look at different limbs and watch the different angles of rotation around, just say, an elbow joint or a knee joint. And with the motion capture, you just place the different markers wherever you'd like to investigate. So we just ran a recent test looking at the upper body and just looking at arms and those movements with respect to the torso. So we didn't even need to put markers on the lower limbs to do that kind of a test.
That's very interesting. We've all seen the simulations of the spacesuits with NASA and the massive swimming pools they have, or I'm sure they call them something else there, inside their labs they're using there, and that's great for the astronauts to train to things. But
Right.
what about situations where they're training to being out walking around in a simulated Mars or moon environment or something like that?
Right, so there's a couple different things there. So with the neutral buoyancy lab at NASA and other facilities, the underwater is the closest you can get to the operations of learning how to operate in zero G. And you can even weight the astronauts out to be in other gravity environments, Mars, Moon. But the element of the actual task is a little bit separated. You can do construction and repairs on space stations, but when you want to look at actual field geology, biology, and the operations, remote simulations in places like even the Utah desert, I call it Mars, because it's the Mars Desert Research Station in Utah, are great places for doing testing. So I'll be going out there for 2 weeks to do a 2-week Mars simulation where I'll be looking at the EVA metrics, the extravehicular activity, so the astronaut out in the field, how far they traverse, the timestamps, the physiological data, heart rate, oxygen saturation, and then also looking at spacesuit mobility inside the habitat and how we send crews instructions on how to take their own measurements of their spacesuits using basic video cameras, and with our lab able to do the analysis of, oh, maybe there's something wrong with the spacesuit shoulder that we need to investigate further on. So it's a great way to interact with crews in remote places as well.
That's a really interesting point, because based on the environment they're going to be in and what they're going to be doing, that really can't be simulated here on the Earth. So you have more of part task type of training, where for this type of a training you're doing it with this simulation, whether it's in the NASA tank or if it's out on the Utah desert, or if it's sitting here doing different pieces with your motion capture. So
that's right. For space exploration, there's only so many different variables that we can match for the destinations we plan to go. And so a combination of all these different locations for training is what's important. So we have places that are out like in the desert, various deserts around the world, that are great for being remote and isolated and have relevant field work. That's exactly what they would be doing in the same thing as impact crater or volcano on one of these other surfaces. But then we have things like the neutral buoyancy lab to look at zero gravity interactions or low gravity interactions and how the body performs in those environments and the equipment.
Well, that's